Hi, I hope you're having a great time with the pandemic because I'm having so. The electric field due to a dipole. So, dipole, as we all know, are two opposite charges of same magnitude that are separated by some distance, say d. And the distance between the center of the dipole to the point where we're going to find electric field is z. Let's call it z. And the distance from the positive charge to the point P is r positive, and the distance from the negative charge to the point P is r negative. So a diagram is it's a great way to visualize what we have in front of us. So we're going to find the electric field due to a dipole, and we know that the electric field in this case is the sum of both the electric field due to the positive charge and the negative charge. So we're going to add that up. Notice that I've put a negative charge in between these two electric fields. That's because the negative electric field due to the the electric field due to the negative charge points in the negative y-axis. So that's the reason for the negative sign. After plugging in the values, we come up with this number. You might be wondering why z minus 1 over d whole square. That's because the r positive is equal to z, which is the distance, as I said earlier, from the center of the dipole to the point P, plus half the distance d. You notice that d, when you get when we add half d to the z, that's the distance between the positive charge and the point P. And similarly, I think I said it for this guy right here, but anyhow, you get the point. Then after a little algebra, we can take the z term out of this expression right here, and we can write this like this. So you guys might remember the formula a plus b into a minus b equals a squared minus b squared from 8th grade. So that's the formula we used here, right here. So but remember, there's an additional square on top of it, so we're going to write it as it is, and then in the numerator we do some simplification like this. So we come up with this term right here. Notice that 1 and minus negative 1 cancels out, and this term also cancels out, and we're left with this. When we add it, we get 2d over z, and the rest is the same. Here's the magical part. Notice that the distance z, which is the distance from the center of the dipole to the point P, is very, very larger than 1. So it means that we can neglect this term right here, because when we divide a number by a very large number, we get close to 0. So we can drop this term, and we're left with this. And we can write this, if we write k in its full form, which is 1 over 4 pi epsilon naught, then 2 cancels out with 4, we're left with 1 over 2 pi epsilon naught p divided by zq. So notice qd equals to dipole moment. That's the formula for dipole moment. So this is the formula we use to find the electric field due to a dipole. Thank you so very much.